Welcome back. In the last video we have seen about line slopes and how the slopes are related in case of parallel lines and perpendicular lines. So in this video we'll see how to find out the distance between 2 points. So to arrive at the formula, let's take a simple example and try to find out the approach we should follow so that we can find out the distance between 2 points. Once we are able to do this, we can generalize this and we can state the formula to find the distance between 2 points. After that, we can do some examples to apply the concept whatever we have learned. So let's start with plotting 2 points for whom we want to find out the distance. Let me say that we want to find out the distance between 3, 1 and 9, 9. So there are 2 points A, B with coordinates 3, 1 and 9, 1. So let me straight away go ahead and try to plot this. So let me take different colors so that I can see the points clearly. So the first point is 3, so this is my 3, and I have to go 1, so this is my 3, 1. Now how I arrived there? I arrived there this way. This is 3, this is 3 and this is 1. This is my first point. Okay, now let's try to plot the second point. What's the second point? 9, 9. So let's see where 9, 9 comes. So first 9 x coordinate. So along the x-axis perpendicular to y-axis 9. This is where I am. Now I have to go another 9. So this is where I will go. So now I want to find out the distance between these 2 points. Okay, now let me plot this also in a color so that you can see. I'm just trying to plot this with different colors so that you can see them clearly. So these are 2 points. This is first point and this is second point. If that color is not visible, this is the first point and this is the second point. Now we have to find out the distance between these 2 points. Okay. Now this is what we know. We know 2 points. We have been given 2 points and asked to find out the distance. So what we did as the first step, we plotted them on the graph. Okay. Now what else we know? We can find out the horizontal distance. Similarly, we can find out the vertical distance between the points, because that's what we are doing since long time, right? Okay, see here, this distance is 3, okay, and this distance is 9. So can I say that this distance is 3 and this whole distance is 9? So starting from here, this whole distance is 9. That means the distance between this point, let me say it as A and B, horizontal distance is nothing but this. We are okay with this? This is the horizontal distance between A comma B, right? Similarly, we can find out the vertical distance between A comma B. So this is the vertical distance between A comma B. How we know? The distance of A, perpendicular distance from x-axis, is this, whereas the perpendicular distance of B from x-axis, this whole right? So let me try to. This is the perpendicular distance from x-axis for point B. Now what is the vertical distance between B and A is nothing but this distance, right? So let me try to put it in blue. This distance is nothing but, let us try to give those values. This distance is 3 and this total distance is 9, so this becomes 6. Similarly, this is 1, the total distance is 9, so this blue length will become 8. Are you with me on this? So what we have done, we have taken the points, we have plotted them. We know how to find out the horizontal distance and vertical distance. That's a, we know only about that till now. So we thought that, okay, let's go ahead and plot the horizontal distance and vertical distance. Okay, so from A to B, this is the horizontal distance, and similarly from A to B, this is the vertical distance. Okay, now let us say that this point is C. So I have point A, point B. What I have done? I have found the horizontal distance between them and I have joined them. If I join them, this is my A, this is C, and this is B. Okay, this is the horizontal distance. So in general we call it as x2 minus x1. We will see that. Similarly BC, we call it as y2 minus y1. We will see that also, right? Now we want to find out this, right? How we want to proceed from here. So one thing which strikes me is that if you look at the line AC, AC is parallel to x-axis, right? Similarly, you can look at the line BC, BC is parallel to y-axis. This is interesting. Now, to find out the distance between 2 points, I have found the horizontal distance and vertical distance, and now I am observing that these two lines seems to be perpendicular to each other. Why? Because the horizontal line is parallel to the x-axis and this line BC seems to be vertical and it's parallel to the y-axis. We know that x-axis is perpendicular to the y-axis because that's how Descartes started this whole coordinate geometry. So I know this is right angle, that means I know this is right angle, right? Now I know that AC and BC are making right angle. I also know the lengths of AC and BC. AC equal to 6 and BC is equal to nothing but 8. Now this seems to be familiar. I have a triangle, to be specific, right angle triangle, where I know the side of length of AC, I know the length of BC. I was asked to find out the hypotenuse length, and we know that formula, d square is equal to AC square plus BC square. Are you with me? So if we take this example, d square is equal to AC square is 6 square plus BC square is 8 square. If you simplify that, that's equal to 100. So D is 10. Super. Now we are able to find out the distance between 2 points. What we did? Let me just join this since we are able to achieve the task. Right. Okay. Let me just give a recap of what we have done. We have been asked to find out the distance between 2 points A and B. Till now, in coordinate geometry, whatever we have learned is only plotting the points. So you give me a point, I know how to plot it in the graph, and also I know little bit about slopes of the lines. Right. Now we have been asked to find out the distance between these 2 points. So since we know how to plot them, we started plotting them on the graph. So then we thought that let us try to find out the horizontal distance and vertical distance between these 2 points, because that is familiar to us and we know how to do that since long time. So we found out the horizontal distance between AC. The distance of A from y-axis is 3. Similarly, C, the distance of C from y-axis is 9. So that gives me horizontal distance is nothing but x2 minus x1 equal to 6. Similarly, the vertical distance is y2 minus y1, that's nothing but 9 minus 1. To be clear, this is your x1, y1, and this is x2, y2. Now we found the horizontal distance and vertical distance. So we found the point C where the horizontal line and vertical line are intersecting with each other, and they are intersecting at 90 degrees because these lines are respectively parallel to the x-axis and y-axis. So once we know that two sides of a triangle making a 90 degrees and we know the lengths, we know that we can apply the Pythagoras theorem. The Pythagoras theorem says that the square of hypotenuse is nothing but equal to the sum of squares of remaining two sides. That means d square is equal to ac square plus bc square. Now we substituted the values whatever we have. AC equal to 6, BC equal to 8, and we arrived that D equal to 10. So this is how we were able to get the distance between 2 points. Now let's go ahead, give generic formula for this, and also we will try to resolve some problems applying the concept of distance between 2 points. Now let's see what is the generic equation. Suppose if x1 comma y1, x2 comma y2, a comma b are 2 points with coordinates x1 comma y1 and x2 y2, then the distance between AB is given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. How we achieved this is pretty simple. This is the point A, this is the point B. Let me try to join them. This is A, this is B, with the coordinates x1 comma y1. Coordinates here are x2 comma y2. Now first let me find out the horizontal distance between them, that is this. What is the vertical distance between them? That is this. I know the horizontal distance. Let's try to plot this point. What is this point? It is the x coordinate of this is nothing but x2, and y coordinate is nothing but equal to y1. So what is this distance? This is a vertical line. On the vertical line, the x coordinate is always constant. So this is nothing but equal to y2 minus y1. Similarly, this length on the horizontal line, y coordinate is constant. You can see it as y1. So the distance horizontally is x2 minus x1. Now suppose this is the distance between AB. We know according to Pythagoras, d square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. If you take square root on both the sides, d is nothing but equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. This is the formula to find out the distance between 2 points. You can remember the formula or you can remember the concept. The concept says that the distance between 2 points is nothing but sum of square of their difference of horizontal distance and vertical distance. That is, the difference between 2 points is horizontal distance square plus vertical distance square. So by that you can arrive that the distance is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. This seems to be pretty straightforward. I think it's clear. So let's move ahead and try to solve some problems. Okay, let's take a simple example so that we can apply and find out the distance between 2 points. Let us say that the points are 3, 5, 7, 8. So A coordinates are 3, 5 and B coordinates are 7, 8. Now we want to find out the distance between these 2 points A, B. Now what the theorem says? Whatever we have found, it's not actually theorem. D square is nothing but, what is my y2 minus y1? You feel comfortable? Just keep them here. 3, 5 x2 y2 is 7, 8. You can substitute directly in the formula, or I can find out this point 7, 5, and I can find out this horizontal distance 4. Similarly, I can find out this vertical distance, which is nothing but whatever you get from the formula. Let's check that. y2 minus y1, that is 8 minus 5 whole square plus x2 minus x1, that's nothing but 7 minus 3 whole square. This is nothing but square root of 3 square plus 4 square, that is nothing but square root of 9 plus 16, that's square root of 25 and equal to 5. What we get from here is same. D square is equal to 4 square plus 3 square, that's equal to 25, which gives me D equal to 5. Now I will give you a couple of sums. You can pause the video and try to get the answers for them. Then afterwards we will do some more sums. Now I am going to erase this. Okay. Now find out the distance between the points 6, 9, 12, 9, and find out what are your observations about these lines. Similarly, there are some other points minus 4 comma 2 and minus 4 comma 7. Find out the distance between AB and CD. I think you are able to get it. The distance between AB is 6 and the distance between CD is 5. And also you observed in these 2 points y coordinate is constant. That means AB is parallel to x-axis. Similarly, CD is parallel to y-axis because in AB y coordinate is constant. Similarly, in CD x coordinate is constant. This is parallel to y-axis. You can check whether you got these values. Let's move ahead. We'll try to solve an interesting example. We have been given that the distance between A 4, 4 and B 10, y is 10 units. We have been given A, B and that the distance between them is 10 units. Find the value of y. Find the value of y. A is 4, 4. B is 10, y. What is the value of y? You can pause the video and try to solve this by applying the formula for finding out the distance between 2 points. Distance between 2 points is nothing but square root of horizontal distance between the points plus distance between 2 points is nothing but square root of x2 minus x1 whole square plus y2 minus y1 whole square. If you take these points as x1, y1, x2, y2, or you can also remember it as distance between 2 points square is nothing but equal to sum of horizontal distance square plus vertical distance square. So without confusing you more, let's go ahead and try to resolve this. Now my formula is y2 minus y1 whole square plus x2 minus x1 whole square is equal to 10 square. So I will say x2 minus x, anyway it doesn't make any difference. You know this is horizontal distance between those 2 points and this is vertical distance. You are squaring them and you are equating them to 10 square. This is nothing but 100. What is my x2 and x1? x2 is 10, x1 is 4 plus y2 is y, y1 is 4. If I simplify this, 6 square plus y minus 4 whole square equal to 100, which gives me y minus 4 whole square is equal to 100 minus 6 square, that's 36. So which implies y minus 4 whole square is equal to 64. Now if I take square root on both the sides, y minus 4 is equal to plus or minus 8. That gives me y value as 4 plus or minus 8. That's nothing but y is equal to 12 or minus 4. You can substitute the value of y here and you can cross check whether you are getting the distance of 10. Let's do it for 1. Let's take 12. 12 minus 4 is 8. 8 square is 64 plus 10 minus 4 is 6. 6 square is 36. So that's nothing but 64 plus 36. What I am saying, if I take the value of y as 10, if you take the value of y as 12, 12 minus 4 whole square plus 10 minus 4 whole square, if you do the square root of them, you will be getting the distance as 10. So, let us do another interesting problem. Let us say that there are 2 points A, B whose coordinates are given by 2x, 3x plus 4 and B is 4x minus 2, 4x plus 3. If this distance between AB is equal to 5 root 5, find out x. If AB is equal to 5 root 5, find out x. You can pause the video and try this sum. You have been given 2 points, so you know x1, y1, x2, y2. You know the formula to find out the distance. The distance is given as 5 root 5. So you can substitute the values of x1, y1, x2, y2 in the equation and you can find the value of x. You can pause the video and try it, and I am about to solve that. So these are the values of x1, y1, x2, y2. This is my distance. Now if I substitute in the formula, x2 minus x1, that is 4x minus 2 minus 2x whole square plus y2 minus y1, that's 4x plus 3 minus of y1, that is minus 3x minus 4, I think you are with me, whole square is equal to 5 root 5 whole square, that is nothing but 25 into 5. 5 square is 25, root 5 square is 5. If I simplify this, 4x minus 2x is 2x. So 2x minus 2 whole square plus 4x minus 3x is x. 3 minus 4 is 1. So this becomes x minus 1 whole square equal to 125. Now this is nothing but, I can see here, if I take 2 out, I will have 1 x minus 1. There is another x minus 1. So I can bring the 2 out. This becomes 4 into x minus 1 whole square plus x minus 1 whole square equal to 125, which gives me x minus 1 whole square is into 5 is equal to 125, which gives me x minus 1 whole square equal to 25. Taking square on both sides, x minus 1 is equal to plus or minus 5. Therefore, x equal to 1 plus 5, 6, or 1 minus 5, 4. So the value of x is equal to 6 or minus 4. If you apply these values of 6 and minus 4, you can cross check the points you will be getting are, the first set of points are 12, 22. These are the points you will be getting if you apply the values of x as 6 or minus 4. If you apply as 6, the values are 12, 22. B is 22, 27. This is for x equal to 6. X equal to 6. Now suppose you can try for the x equal to minus 4 and see what coordinates you get. You should get minus 8. Let me write them down here. For x equal to minus 4, you will be getting the values as minus 8, minus 8, minus 18, comma minus 30. You can cross check and see this. So that's about, in nutshell, about distance between the points video. What we did in this video is we took a simple example, and with the knowledge whatever we have in coordinate geometry, we tried to arrive to find out the distance between two given points. Once we are able to find out the approach, we have made it generic and find out that the distance between 2 points with coordinates x1 comma y1, x2 comma y2 can be given by square root of x2 minus x1 whole square plus y2 minus y1 whole square. Nothing but distance between 2 points is square root of their horizontal distance square plus their vertical distance square. After that, we did couple of sums to apply the concept. In the next video, we will start with equations, creating equations for different scenarios. Line equations, we will see point slope form, 2-point form, 2-intercept form, and some more interesting scenarios. Catch you in the next video. Thank you. Bye bye for now.